We didn't talk about this already, did we? No. Okay. All right, so for our programming philosophy, the idea behind this is that you should be an engineer who happens to know how to program or knows how to program enough to get the job done. Do not want you to become a programmer who happens to be an engineer. So sometimes you'll run across somebody in a company or a conference or something like that, and they start talking to you about this C++ compiler or that C++ compiler, or whatever it happens to be, and don't feel like you didn't get a proper education if you don't know what that is, because what happens is those guys are actually computer programmers. They're not engineers. Okay, so the idea behind this is that you have the ability to understand what the problem is, not just write a bunch of code that you don't know what it means. All right, so the objective here is to make you an engineer who happens to know something about programming. All right, so we're going to take a thing called a divide and conquer development approach. What that means is, when we start the applications, we're going to start out with a relatively simple program, and then we're going to add additional components and sophistication. So what that means is you're going to end up with incrementally different programs, and you'll probably end up with maybe 4 or 5 major assignments for this section of the course. And it's very important that you keep up on this. If you fall behind, okay, you're going to be in really big trouble. So if you fall behind, you need to come see me, or you need to come see the TA, because each new section we go on requires the previous section to operate sufficiently in order for your next assignment to work. So you need to make sure that you have everything working as we go each step. All right, so that's our divide and conquer development approach. If you were to try to solve this whole thing we're going to be doing, this application that we're going to be developing, it would become horribly burdensome if we were to try to do the whole thing at one time. So we're going to bite away at it in little pieces. Saving programs, I mentioned this before. Use a numbering system for each version. Save the program on a continuous basis, even during a single development session, and you want to back up to multiple media in different locations, just in case your USB happens to go through the washer or something like that. All right, so as you go and you start working on your program, it's very important that you comment your program. And in fact, I'm going to tell Saida that you have to have program comments in there, otherwise you can't get full credit for it. So comments do a couple of things. One is it helps you while you're developing the program. So sometimes you may get so embedded into the program you forget what you're doing because it starts getting so complicated. So there used to be a thing called pseudocode a number of years ago. Basically what you did with pseudocode is you kind of wrote down what you wanted the program to do in English, and then what you did is you tried to translate that into whatever programming code that you were using. With the program, a program like Visual Basic for applications, half of the commands, statements you're going to use are in English, so you can kind of tell what you're doing. So it's not as burdensome as it was before, but you still need to know what you're doing. So you need comments to help you remember what you're trying to do. It's also very important in the event that you ever use a program sometime after you developed it, so you can understand what's going on. I don't think that there's been a program written on the face of the earth of any significance that has not had bugs in there, so sometimes you have a program and there'll be bugs that are in there. I once worked on a project for the Bureau of Mines, and the program was actually 20 years old. People kept writing and adding parts to the program for 20 years, and they did all kinds of bad programming techniques, which we'll talk about in a minute here, and it turned out to be like this horrible mess. And the reason why I got involved in it was that the Bureau of Mines, they had full-time staff, they're engineers. The reason why I got called in there was because the program was such a mess, okay, it got to the point where they couldn't even use the program anymore. And so they wanted it to do something specific, and so that's how I got involved when I was a graduate student 1 year. All right, so the other thing you want to do is you want to decide how you're going to comment it, and so there's two different types of comments here. One is one at the program level. So at one of the opening screens or early in the program, you want to have these different versions, okay? You want to explain what you did. So for example, you might have a new enhancement, a new module that you put in there, additional capability, or you may be fixing a bug in it. And so a lot of times what happens is you'll see people that have bugs in their programs, and they have bugs in their programs, and they try to deny that it's a bug, okay, and they say, well, it's like a feature, okay, but it's actually a bug, okay? Just encountered that myself the other day. I was using this piece of software, and I asked them about it, and they said, oh, no, we could do that in an ideal world, but we don't really need to. And so I think they just didn't want to recompile their program to fix the bug. All right, so then the other type of commenting is at the structural level, and this is what the structure actually does, okay? So this is where you're talking about like having a pseudocode type thing. Now, what does this mean? Job security. Okay, this is, as far as I'm concerned, the only acceptable reason not to comment something. Okay, because even if you comment it, you may not know what it's doing. Okay, and so if you don't comment a program, nobody else is going to understand it either. Okay, so I have seen situations where people deliberately don't comment programs because they do not want anybody else messing with their code. That isn't acceptable as far as I'm concerned, reason why you would want to comment something. But this is a conscious decision, and this does not apply to this particular course. You're expected to comment everything because nothing that we do is so earth-shattering that you need to make sure that nobody else knows how to do it. Okay, so comment. Going to be expecting comments in at least 2 different ways in the program. All right, so let's talk about program organization. We'll talk about these different things. Okay, so the first thing is there's a thing called spaghetti code, and if you look at a plate of spaghetti with meat sauce on it or something like that, that's pretty much what the spaghetti code is. The program goes in one part of the spaghetti, and you don't know where it comes out, you don't know where it starts, and so on. And so it's this style of programming which prevents the program from being understood because it like hops all over the place. So there was a guy here, Dr. Charles Donahue, who was here, retired, I don't know, about 7 or 8 years ago. He used to practice a lot of spaghetti code, and he also did some other stuff. And he named subroutines. Instead of naming a subroutine after what it did, he would name it after his kids. Okay, so it just like became totally crazy because one summer he and I sat down and we took a lot of his programs and we ported it from a thing called Quick Basic, which was the precursor to Visual Basic, and we ported it to Visual Basic, and I had to actually have him sit down in a seat next to me, and when I translated the code from Quick Basic to Visual Basic, I kept having to ask him, what does this mean, what does that mean? Okay, because he had no commenting in the program, and he also had these crazy names for variables and subroutines. All right, so one of the ways that this is implemented overtly or inadvertently is through the use of something called a go-to statement. Okay, so you have a particular section of code, and then you have this go-to statement there, and then it just hops to some other part of the program, and then once it gets to that point, it hops to some other part of the program, and you never end up back where you are. So when that happens, you can't tell where parts of the program start or stop, and it makes it extremely difficult to even figure out what's going on. But if you have a bug in there, it's very difficult to find out where the bug is and how to modify it to fix the bug. Okay, so the use of the go-to statement in the kind of programming we're doing, which is called structured programming, is a cardinal sin. It doesn't cause you to have physiological problems, okay, other than perhaps pulling your hair out or something like that. But you don't want to practice it. There is actually one time you might use it, and that's for like error trapping, the way that errors are trapped. But if you do proper programming technique, you can trap the errors without using the go-to statement. It's actually a statement that says on error go to. Okay, that's if you have some kind of really crazy situation. All right, so we don't want to use spaghetti code. We want to use this thing called structured programming, which means that for any given type of code, that there's only one way to get into that structure or that segment of the code, and there's only one way to get out of it, okay? All right, so you can use the pseudocode to figure this out, and then the other thing you can use is you can use a flowchart. People are graphically oriented, and so if you have really serious problems trying to figure something out, okay, one of the ways that you can try to make sense of something is if you have a flowchart. The problem with flowcharts are people do not they do not update them. So you have a program and you find out that it's fundamentally flawed because of your logic, and what happens is people start altering their code, but they don't update their flowchart. So if you want to properly use this, then you need to actually update your flowchart every time you find out that you have some serious problem. Most flowcharts are at a high level though, and so as long as you don't have to do something really egregious doesn't happen, then your program might be at a high enough level for you not to to understand how the program's working, but not so much that you're involved in debugging some minute thing. Okay, so a flowchart is a graphical representation of the flow of the program and provides a general understanding of how the program works. And as we've been talking about, it's very helpful in the development and debugging. So you should actually create a flowchart before you actually start doing anything, and that will give you an idea of how your stuff is supposed to work. All right, so there are some standard flowchart symbols: oval, rectangle, tilted parallelogram, and diamond. And there's some other ones that can be used, like for do, while structures, but you can still do it without them. But these are the ones we're going to talk about. Okay, so the oval in a flowchart is used to designate both the start and the stop portions of the program. Okay, so it's like an explicit situation: start and a stop. And you'll notice how the start and the stop only have one way that they can go in. Okay, you don't want to have them coming in or going out in different ways. You can only have things go in one way or go out one way, which is the concept of structured programming. The way the charts go is generally down and to the right. Okay, so try to avoid doing something crazy like that. If you use some kind of automated program, I think there's one called Visio, and I'm sure there's others. If you press a magic button, okay, and you have this thing generated, it's going to do all kinds of crazy stuff. Okay, so my expectation is in your assignments, what you're going to do is you're going to manually generate the chart. None of them are going to be so sophisticated you're going to have a problem with it, but you can manually generate the chart in PowerPoint using the auto-connect things, and it shouldn't get too crazy. All right, so one is the oval, represents the start and stop process. The rectangle. This is used to represent general purpose processes, and in keeping with the structured programming thing, you're either going to come in through the top or you're going to be coming in through the side, but you can only come in through one way. Okay? If you need to enter it some other way, then what you're going to do is you're going to make the line go into the arrow that feeds into it. Okay? Similarly, when you exit, it's either going to come out the bottom or it's going to go to the right, and again, it can only do one or the other, it can't do both. Okay? So this is representing, what it does is it represents a process. So for example, this would be a process that calculates the mean of a set of data. Okay, so that's the rectangle. There's a thing called a tilted parallelogram, and what this involves is some sort of input or output. So input could be you're going to get numbers from the keyboard, or it could be inputting data from a key stroke, like your programs will work. Like you're going to hit an A for an arrival, or an S for a service start, or an E for a service end, stuff like that. And it can also be if you're going to be outputting something. So, for example, if you are going to display something on the screen, whether it's just one little message or whether it's some summary statistics, that would be also an input-output process. Okay, so again, like the rectangle, you're going to enter from the top or the right-hand side, and you're going to leave from the bottom. Sorry, you're going to enter from the top or the left-hand side, and you're going to leave from the bottom or the right-hand side. Okay, so the tilted parallelogram represents an input process, or it represents an output process. All right, so then we have the diamond. And so The diamond represents some sort of decision, some sort of logic structure that you have. Okay, so you're going to come in from the top, or you're going to come in from the left-hand side, and there are two ways of going out, but you can only go out one way at a time. Okay, so typically the decision that's in the diamond is going to ask you something, it's going to assess something, so it's going to be associated with an if statement that evaluates a condition, and so you're going to have the things coming out of the right and the bottom are either going to be yes, or no, or true, or false. Okay? Sometimes there's a temptation to come out this side, but I want you to avoid that. It's better to go yes. Typically what happens is if you have a condition that works, you're going to have like a smaller amount of code and a larger amount of code involved in the process there. Okay? All right. Okay. All right, so that's the diamond. All right, so let's look at the kind of sort of what you guys are going to be doing. You're going to be doing something more sophisticated, but just to put it all together, we'll just go through an example here. Okay, so this is a simple process. You have to start, you have to stop. Okay, so you have to input a piece of data. Okay, then the next thing is there more data? And if the answer is yes, you come up here, and then you have to come up here to go back in. Okay, you keep inputting more data until you don't have any more data to input. And then when you have all your data in there, you want to calculate the statistics, and then you would want to actually display the statistics. Okay, and that would be an end. Okay, so here's a simple example of how these different structures, these four different structures, would be implemented in a simple program. Okay. All right, so let's talk about a thing called mnemonic naming conventions. Okay, so you're gonna have variables, and you're gonna need to keep the variables something. They want to be based on something that helps you know what they are. So that's one thing. Okay, another thing is you can't have something that conflicts with the reserved name. So there are some reserved names or statements. Reserved names for statements or functions that you can't have them conflict with. Okay, so here are some good examples. Okay, obviously what this means is the mean. Okay, and this means the standard deviation. Okay, and this is a value for it. Okay, you may have other structures that are associated with the mean, but they're not actually the value. It could be something that's associated with displaying it or calculating it and so on. Okay, some bad examples: val 1. Result 1, stuff like that. Those are totally unacceptable because you have no idea what they mean. Okay, so make sure that you name your variables. Anybody see that movie called Johnny Mnemonic with Keanu Reeves in there? Possibly made before you were born. Okay, you probably looked that up on the internet. All right, subroutines. Okay, there are these things called subroutines, and again, subroutines should be named based upon their operations, and again, they can't conflict with any kind of reserved name. And so a good example of that would be calc the mean, or calculate the mean. Bad examples would be things like calc, we don't know what you're calculating, or another one would be mean. We don't know what the mean that you're doing. All we know is it's got something to do with the mean. We don't know what it is. Okay, so what you want to do is you want to have your subroutines that you have in your program, which are subsets of the program. You want to have those mnemonically named as well. Okay, now let's talk about some Visual Basic stuff now that we know some of that. Okay, so the idea behind Visual Basic is that you can use an application like Excel in particular, although you can also do it in Word. The program that I think the department is still using for simulation is a thing called Arena, and you can also create a customized calculations and interfaces using VBA. And so what happens is VBA is used to add in additional flexibility in these programs that would not ordinarily be possible. So it's included in Microsoft Excel, for example, for free. As we've talked about, it's based on Microsoft Visual Basic, and it can actually be used in several different ways. If you're a masochist, okay, what is a masochist? You like to hurt yourself. Okay. If you like to hurt yourself, okay, you could actually do some fairly sophisticated things using Excel macros. Okay. Macros are like a bunch of keystrokes that are involved. And when I was at the Michelin Tire Corporation, the predominant language at that time was a thing called Lotus 1-2-3. And I could not believe the things that people were trying to do with Lotus 1-2-3. But the reason was because they didn't know any better. They didn't know how to program anything. Okay, so they were doing these ridiculous things in Lotus 1-2-3, literally recording hundreds of keystrokes, okay, to try to automatically process some data. So this is ridiculous. And the whole reason was because the person didn't know how to program. All right, so you can use it a couple different ways. Okay, one is you can use it as a facilitator for Excel operations. You want to do a particular type of thing in Excel, and it's difficult to do it in Excel, so you can make it whatever you want to do, make it a little bit easier. Another way is you can make it a complete front-end interface to Excel. Okay, so in other words, what the person sees is they only see like these little screens that you make. Forms are the technical term for them. And then it's also possible to make a complete programming language of it. And so when you give the application to somebody, okay, let's say you give it to somebody that works for you, you give them the Excel file, and they can't mess with it. Okay, the way you program it is so robustly that they can't take the data that's being stored in the Excel worksheet, and they can't corrupt it. Unless they really try hard, and that's one of the things is you don't want someone to have access to too much stuff, otherwise they might mess it up. All right, so the idea is we're going to exercise or use Visual Basic applications where it's appropriate, and then we're also going to use the Excel functions where those are appropriate. You could program anything that you do in Excel and VBA, but it's already there in a lot of cases, so why bother? If you can access it much more easily than you could having to program it yourself. All right, so that's what Visual Basic does. Okay, so here are some general things. That you have to do with Excel. You have to launch it. You have to, depending upon what edition version you're using, you need to get the Visual Basic applications working. Sometimes it's under File Options, the Customize ribbon, and then check Show to have the Developer tab come up. So you'll have to figure that out. And then what happens is the program works two different ways. One way is design time, and when you're doing it in design time, what you're doing is you're creating the program, and it uses a thing called the VBA editor, and you still run the program. But you're developing it, and then when you're actually running it and you're in runtime, what's happening is the user is going to interact with the program, and that can be based upon the Excel worksheet that it's going to be in. When you put in a Visual Basic application modules inside the workbook, you can't save it as a regular workbook. You have to save it in what is known as a macro-enabled workbook, which is slightly different. So in that thing where you have like a list of different things to save it in, you need to make sure you check the right one so it doesn't dump all your stuff. If you don't put that in there, you're going to lose all your stuff, or could potentially lose all your stuff. The other thing that you might encounter is a thing called macro security. Somewhere in the little dongle menu, it might ask you about macro security, and in which case what you need to do is you need to put in trust access for that. Okay, so there are a few administrative type things that you need to do. Okay. All right, let's talk about the editor, the thing where you are going to be developing a program, design time. All right, so the way you do it generally is you go to the Developer tab in the top of Excel after you've added this in so it appears. and then you go to the Visual Basic icon. I think Alt F11 will still work. And so what the VBA editor does is it contains menus, menu bars like any other program. It has a thing called the workspace, the project explorer, the toolbox, and a properties window. Sometimes these get closed down and you have to open them back up depending on what you're going to be doing. And what's so funny about this is back in the 1990s, was when Visual Basic first came out, or not Visual Basic, when, Visual Basic came out, version 1.0. And up until that point, a lot of people were running around that knew a lot about programming. And as soon as they started using Visual Basic, okay, this thing would come up, the VBA editor would come up and they'd say, what the heck is that? Okay, how do I use that? And so going from a textual-based type situation where you're programming and compiling stuff, and going to this graphical-oriented phase was a quantum leap. And when I first came here in 1995, there were many faculty members that were involved in the lower-level programming courses that's all they knew. Okay, all they knew was how to get a text editor, how to write some code, how to compile it, and then how to run it. And the whole thing was textual-based. And so when I started doing the Visual Basic thing, a lot of people got very upset about that because they had no idea what that was, and they got upset about it. All right, so I think I'll kind of do this in tandem maybe. All right, so I'm going to try to do this at the same time.